Good evening, everybody. Today we're gonna learn what is homolytic fusion and what is heterolytic fusion. Uh, First, I would like to remember you that fission means breaking or cleavage. So before discussing these two topics, gonna uh, I am gonna teach you something that is very much important for you. So keep patience, right? In every reaction of organic compounds involves the breaking of at least one bond and the making of another bond. That is, without breaking and making bond, no reaction happens, right? To break a bond, in fact, we are breaking down a molecular orbital to give or produce atomic orbitals, right? I think you have understood this line. My question to you is that why do we need supply energy to break a bond? Usually we know that if we want to break a bond, then we have to supply some energy. But why we should supply some energy to break a bond? Can you think? Well, if you can answer this question, then I think you understand chemistry. Well, the answer is here. We know that molecular orbitals in molecule are at lower energy, that is, more stable, than the atomic orbitals, right? Therefore, energy has to be supplied to break a bond. Again, why should we supply some energy to break a bond? The answer is here. We know that molecular orbitals are at a lower energy, that is more stable than the atomic orbitals. Therefore, energy has to be supplied to break a bond. I think now you are clear. Well, a covalent bond, that is the sigma bond, right? A covalent bond can undergo fission in two ways. That is, in two ways we can break the covalent bond. The first method is homolytic fusion or homolysis, and the second method or process is heterolytic fusion or heterolysis. Step by step, we'll learn about these two terms. Okay, first we are gonna learn homolytic fusion, right? Homolytic fusion. See here, there is a one pair of bonding electron between these two atoms, right? And everyone is sharing this pair of electron. Okay. Uh, in homolytic fusion, uh, they both atoms will take equal amount of electrons. So this atom will take one and this atom will take one. So these are neutral species, right? Neutral species, and these species are called free radical. Homolytic fusion is the chemical bond dissociation or breaking of a chemical bond decision or breaking of a molecule, right? Homolytic fusion is the chemical bond dissociation or breaking of a molecule. In this process, that is in homolytic process, each of atoms acquires one of the bonding electrons, right? One of the bonding electrons. That is, homolytic fusion is that kind of fission in which every atom related to bond will take equal amount of electron when the bond will be broken between them. Okay. Well, here is a specific example, chlorine, right? By homolytic fission, we are getting chlorine free radical. Well, the product A and B are called free radicals. They are electrically neutral, have one unpaired or odd electron associated with them. Okay. Especially homolytic fission is the most common mode of fission in the vapor phase. Homolytic reactions are usually initiated heat, light, or organic peroxide. So these are the basic information about homolytic fission and homolytic reactions. So now we are gonna to learn about heterolytic fission. Well, this is a molecule, and when we are going to break this bond, only one atom are taking all the electron of this bond. As a result, A is going to be positive and B is going to be negative, right? Or if A take all the electron of this bond, then A will be negative and B will be positive, right? So heterolytic fission or heterolysis is the process of cleaving or breaking a covalent bond, right? In this process, one of the atoms acquires both of the bonding electrons where the bond is broken. Here is the proof. The products of heterolytic fission are ion. This is positive ion, this is negative ion. Here is a specific example, right? The electronegativity of chlorine is much more greater than hydrogen. As a result, here homolytic fission will be happened. So we'll get ions. One is positive ion and another is negative ion, which is chloride. So thank you for viewing this video. If you have question on this video, you can ask that question in the comment box below. I will try to answer your question. Thanks for viewing this video. Be well.